Hi, welcome to my channel. In the previous video, we discussed about the definition of decision tree, and also some of the terminals of the decision tree like root node, intermediate node, and leaf node. And also we discussed about some of the types of decision tree algorithms like ID3 algorithm, C4.5 algorithm, and CART algorithm. And also we discussed about how to training a decision tree, and how to visualization of the decision tree. Okay now. So now in this video I am going to explain about what the importance of the Gini impurity or entropy. That means here we are having the different types of decision tree algorithms are there, like ID3 and CART algorithm is there, CRT. So internally entropy, one of the parameters there. That parameter is going to be used in order to construct the decision tree with the help of ID3 algorithm. Okay. Whereas in CART algorithm, internally it uses the concept of Gini impurity. Now we are going to discuss when we are using the Gini impurity or entropy with the details. Okay. Now here the Gini impurity is there. The Gini impurity or Gini index is going to be found out with the help of some formula, that is a Gini index of target variable equal to 1 minus sigma of I equal to 1 to m pi square. That means we are going to find out the Gini value of the corresponding target variable with respect to each and every class variable or each and every attributes. Okay. So here we are going to do the one more thing is that is called as a Gini index of target variable. Okay. The target variable with respect to corresponding attribute value equal to mod of S1 by mod of T into Gini of target variable, Gini of mod S1 into, okay, plus mod of S2 by mod of T into Gini of S2. So here the S1 is nothing but the subset 1. Okay, the subset 1, the total number of elements in the subset 1, and T nothing but total number of elements in the entire data set. So that is the T. So Gini of corresponding S1. Okay, you have to find out the Gini index of the target with respect to subset S1 plus mod of S2. Mod of S2 nothing but the subset 2, the total number of elements in the subset 2 by the total number of elements in the entire data set into Gini of S2. So with that we are going to find out the delta Gini value. Based on that we are going to find out the root node. Okay. And whereas coming to entropy HI equal to 1 minus sigma of k equal to 1 to n pi k not equal to 0 pi k into log of pi k base 2. So that gives the entropy of the corresponding variable. Okay. Now here the Gini impurity measured is used in the as a defaultly. Okay. Here that means in the if you want to construct the decision tree with the help of decision tree classifier that is present in the sklearn. Okay. So here the default parameters are there. The default parameter is Gini value. The criterion equal to default criterion equal to Gini value only. That means internally it uses the concept of CART algorithm. Based on the CART algorithm, we are construct the decision tree. If you look into the sklearn.tree, that will provide the implementation of the decision tree classifier concept. Okay. Internally it uses the concept of decision tree. Okay. Criterion equal to Gini. So the decision tree classifier has the different hyperparameters are there. So internally the default value is the Gini value only. So that means the by default automatically we are implementing the CART algorithm. That is the main concept. Okay. But if you want to select the entropy as the measure, okay, instead of setting the criterion hyperparameter to the entropy. That means if you want to implement the ID3 algorithm, then you have to select the criterion equal to entropy in the decision tree. Okay, then only we are going to implement the ID3 algorithm. That means it uses the concept of the entropy concept. Okay, so like that we are going to select the which one you want to implement. That is if you want to implement the ID3, you have to select the criterion equal to entropy. Suppose you want to implement the CART algorithm, automatically the default value is Gini value only. You don't set any value as a Gini value. Default that is available in the decision tree classifier. So that is a major difference between the how to select the corresponding algorithm. Okay. Now the concept of entropy is originated in the thermodynamics. Thermodynamics one subject is there in mechanics. Okay. In that thermodynamics as a subject, in that subject a measure of molecular disorder is there. So that concept was discovered by the entropy. Okay. Now entropy approaches the zero when all the molecules are still and well ordered. So that is the main originator of the entropy concept. Okay, that is used in the thermodynamics. Now later entropy is spread to the wide variety of domains like Shannon information theory, where it measures the average information content of a message. Okay, entropy is zero when all the messages are identical. So here whenever the entropy value equal to 0, that means all the information is there, all the information, okay, that are identical, all are equal to same concept. Okay. Now in machine learning also, entropy is frequently used as a impurity measure. If the entropy equal to 0, that means all the elements are belonging to the same class. If all the elements are different classes, then they are belonging to impurity class. So here entropy is frequently used as a impurity measure like Gini index value. Okay. Now a set's entropy 0 when it contains instances of only one class. That means if the entropy equal to 0, all the elements in the corresponding class, group contains the same class only. That is the main importance of the entropy. Now, for example, here we are having the one data set called as the iris data set. In this iris data set, we are having the 4 features are there: sepal length, sepal width, petal length, and petal width. These are the 4 features, and the corresponding class labels are setosa, versicolor, and virginica and versicolor. The 3 class labels are there. So in our model, we are going to implement the decision tree classifier with the help of criteria equal to entropy. That means we are implementing the concept of ID3 algorithm. For that ID3 algorithm, we are giving the x and y. Here the x is nothing but we are using the petal length and petal width features only. We are providing only 2 features. Okay, and petal length and petal width as a x and y is providing as a 3 class labels like species. Okay, it contains setosa, virginica, and versicolor. These 3 class labels are there: virginica and versicolor. Okay. Now, so the entirely this data set contains 150 rows and 4 columns, 4 features are there, and one corresponding 1 class labels are there. Okay, so totally 150 by 5 columns. So out of 150 by 5 columns, we are selecting the 150 rows and 2 features and one corresponding target variable. Okay. Now here we discussed about how to construct the decision tree with the help of Gini value. Okay, already we constructed the decision tree with the help of Gini value for the given data set like iris data set. Okay, now we are going to find out how to find out the value of entropy for the given data set. Okay. Now here entropy is there. Entropy is we are going to find out the help of one formula that is equal to HI, entropy of corresponding element I equal to minus of sigma k equal to 1 to n pik not equal to 0 pik log pik base 2. Okay, here for example here we'll see one example like here the Gini index value is there. Okay, in the left node at depth 0, depth 2. So 0, 1, at 2. So for example, here our data set contains iris flowers data set, iris flower dataset, and it contains 4 features. Among the 4 features, we are selecting only 2 important features, that is petal length and petal width, and class labels are setosa, versicolor and virginica. Here 3 class labels are there. Now we are going, our aim is we have to find out the represent the class label for each and every attribute. Okay. Now first of all, we are checking the condition. The condition is if the petal length is less than or equal to 2.45, then we are going to divide that into 2 parts. So here we are having the 150 samples are there. Out of 150 samples, so 50 are belonging to setosa, 50 are belonging to versicolor, and 50 are belonging to virginica. Now among all the 50 elements, all the 150 elements, the condition, the first criteria equal to petal length is less than or equal to 2.45 centimeters, then those belong, if the condition true, then we are going to left node. Otherwise, we are going to check the other condition. Okay. So here, what happened, ma'am? Here, this condition true, that means only 50 elements are 50 instances are satisfied this condition, and remaining elements are not satisfied this condition. So these 50 elements are belonging to one class. So here value equal to 50, 0, 0 means all elements are belonging to same class, and 0 belongs to versicolor, and 0 belonging to versicolor. Now here we are finding the Gini value. Already we know what is the formula for the Gini value. Okay, here the Gini equal to 0.0 means all the elements are belonging to same class, setosa, that is a class name is setosa. Like that, we are going to find out the entropy for each and every attribute here. Okay. Now, for example, here we are going to check what is the entropy of our data set. Okay. So this is the level 0, level 1, and the level 2. So we are looking to the depth of at the depth 2 left node, at depth of depth 2 of left node. Okay, so this is the node. Okay, at this condition we are having the total number of elements are 54. Total number of elements are 54. Out of 54 elements, 0 elements are belonging to setosa, and 49 belongs to versicolor, and 5 are belonging to virginica. Now we are going to find out whether all the elements are belonging to same class or not with the help of entropy. Now we are going to find out the entropy for this data set. So here we are having the formula called as entropy equal to minus of sigma k equal to 1 to n pik not equal to 0 pik log to pik. Okay, here that means we are going to find out the entropy. Okay, the total number of elements in the entire data set equal to minus of by 54. The total number of elements are 54. Out of 54 elements, 0 elements are belonging to setosa. 0 elements are belonging to setosa. That is a 0 into log 2. This is 0 by 54 into log 2 base 0 by 54 minus the next elements are belonging to 49 by total number of elements are 54 into log 2 49 by 54 minus 5 by 54 into log 2 5 by 54. That gives them the value of as a 0.445. That means here instead of Gini value equal to 0.168, we are having we'll get the entropy equal to 0.445. That means all the elements are not the same class. So already we discussed what will happen if the entropy equal to 0 and the entropy is not equal to 0. If the entropy equal to 0, that means all the elements, that means all the samples here 54, all these are belonging to same class. But what happened here? The entropy equal to 0.445. That means they are not all the 54 elements are not belonging to same class. So we can further split this node into different parts. So that is the main aim of the entropy. Okay. Like that, the entropy or maybe Gini value are going to use whether the elements are going to be split the further process or we can stop the process. If whenever the entropy or whenever the Gini value equal to 0, we can stop the process. Otherwise, we are going to split the data into further level. That's the main difference between the entropy or Gini value. Now, so when you use the Gini impurity or entropy, so here the truth is the most of the time it does not make a big difference. They lead to the similar trees only. So with the help of if you are using any Gini value or entropy value, we can construct the decision tree only. But the way of different representation of the data is very different, but the concept is the same only. Okay. Now the Gini impurity is slightly faster to compute, so it is good by default. Okay, it is a very simple one, and we can easily faster to construct the decision tree. Okay, it is a very simple one. So the Gini impurity is the best one compared to entropy value. But however, they differ. Gini impurity tends to isolate the most frequent classes in its own branch of the tree. So that is the difference. Whereas coming to, while entropy tends to produce the slightly more balanced trees. Okay, so that is the major difference is the difference between the Gini impurity and the entropy. Now, like that, we are going to construct the definitive result of Gini index value or entropy value. The both will construct the decision trees only. Okay. In the next video, I am going to discuss about the regularization of hyperparameters. Thank you for watching our video. If you like the video, please subscribe my channel. Thank you.